slope of this line is equal to the velocity. Okay. A similar model is a model of a particle moving under the constant speed. We have that a particle if we have a particle moving with a constant velocity, if a particle moves with a constant velocity, it means that it moves with a constant speed also, right? But if a particle moves with a constant speed, it's not necessary that it moves with a constant velocity, because the speed is the magnitude of the velocity. Constant speed, not necessarily constant velocity. We may have the constant speed, but the direction of the velocity change. Anyway, for a particle move in one dimension, constant speed mean constant velocity. Okay, just for the one-dimensional motion. And we can write down the speed again. The definition of the speed is a distance over time, the duration that the particle moves, like this equation. Okay. We now have the definition of position, displacement, the velocity, and also speed. We now come to the last quantity in this chapter, which is the acceleration. By definition, the acceleration is equal to the change of the velocity, the ratio of the change of the velocity to the time. Okay, we say the velocity here, and as I have mentioned before, that this is the instantaneous velocity, and this is the definition of the acceleration. The dimension of the acceleration is the dimension of the velocity over the time, and since the velocity, the dimension of the velocity is L over T, the dimension of the velocity over time is L over T square. Okay, and in SI unit it is a meter per second square. And as in the case of position and velocity, when we talk about the motion in one dimension, we can use the sign, the positive or negative sign, to indicate the direction.